Quite a view, huh? But I'm not here just to look at the view. Maybe I better explain that. To begin with, this is a movie. And in a movie, anything can happen, including me. For instance, if I want to turn upside down, I snap my fingers, just like that. And there you are. Or rather, here I am, upside down and none the worse for it. But enough of that. You see, in a movie, you can do almost anything you want to, provided everything turns out right in the end. And that's my job, see to it that it does. Sometimes that isn't easy, believe me. Take this case. You ever hear of one Elmer Payne? No? Well, Elmer's actually like a lot of people you know, only a lot more so. He's the kind of fella that, well, let me show you. Yes, that's Elmer Payne. And that's his car. No, he doesn't collect them. That's his only car, and he loves it. Just as good as the day he bought it, Elmer often says. According to Elmer, they just don't make them like that anymore. Solid. Built to last. Elmer never did hold with any unnecessary novelties and improvements. The less of them, the less to go wrong, he says. And he has the figures to prove it. As a matter of fact, Elmer has the figures to prove almost anything. That's the greatest pleasure Elmer has, keeping track of things. You can't argue with figures, Elmer always says. Now, every day at exactly 8:57, just as regular as clockwork, Elmer parks his car in the lot near his office. More regular than clockwork. That leaves him just 3 minutes to get to his office. Elmer Payne. Some people call him the pain in the neck of progress. But Elmer serves a purpose. He's the voice of the past, the company's wet blanket, the brake on others' enthusiasm. And that's how Elmer gets to be in this story. Watch now, and you'll see what I mean.
Good morning, Mr. Knapp.
Good morning, Elmer. No. Sit down. Hard at it, I see.
Yes, sir. Haven't missed a day here in 20 years.
20 years? Oh, yes. That must have been when we were putting up that building at 1010 Main.
Yes, sir. And I don't mind saying that I evaluated the estimates on that job. But we had trouble.
You had trouble?
Yes, sir. Architects and engineers insisting on all sorts of innovations and newfangled ideas, running up costs.
But you put them right. Get the costs down.
I certainly did. Without sacrificing one single iota of strength or solidity. Why, that building was really built to last. Solid, sturdy.
Yes, but what we can't understand is we're having trouble renting space in that building.
I can't understand that either. Why, we've painted regularly, and just last year we redecorated the entire lobby and hallways. I have all the figures here. Why, maintenance alone has cost us...
Despite the money we've spent, our tenants are leaving. If we lose one more, and that building will be running in the red. Losing money.
Losing money? Somebody should look into that.
Exactly, Elmer. Particularly with the new building about to go on the drawing boards. What we need is a troubleshooter. Somebody to get in there and dig out the facts on 1010 Main and then follow through on the new building. We don't want the same thing to happen with it. Oh, yes. We'll need somebody to look after things. Somebody on whom we can rely implicitly.
Of course.
Somebody that's unlikely to be swayed by innovations and extras.
Oh, naturally.
Somebody that has the profits of the company at heart.
Yes, that's most important.
Somebody that was in at the beginning of 1010 Main.
Yes, background is important.
In short, you.
Me? But I wonder if I'm the right person.
Certainly you are. You're reliable. You have our profits at heart. You're unlikely to be swayed by anything. Besides, by your own admission, you did such a fine job on 1010 Main. Who is better qualified to find out what's wrong there now?
Well, I suppose you're right.
Well then, Elmer, the architect and engineer are ready with their proposals on our new building. You check with them and report back to me.
Yes, mustn't let them get out of line.
That's right. We want this building built right. Not only up to date, but up to the future.
Up to the future?
That's right. And Elmer,
Yes, Mr. Naxon?
enjoy yourself, Elmer.
Enjoy myself.
Well, that's how Elmer got away from his roll-top desk for the first time in 20 years. For Elmer, a most unnerving experience. Particularly unnerving, for on arriving at 1010 Main, he discovered that another tenant was moving out.
Our company, Mr. Payne, as you no doubt know, was one of the first tenants of this building. I can assure you we have no intention of being the last.
But we've done everything, spared no expense to keep our tenants comfortable here.
What's the trouble, Mr. Payne? Hot? Well, we've been hot for years. Hot under the collar. Too hot in summer and too stuffy in winter. 20 years ago, employees didn't expect comfort. Now they do. Do you know what it costs to replace just one employee? And they've been leaving us in droves. Our typists are ruining their eyes, and our correspondents because they can't see by inadequate lighting. You came up on the elevator, 1 floor a minute when they're working at all. We wanted to put in a battery of new modern office equipment to increase output. We offered to install our own air conditioners, but no.
But I'm sure the power company wouldn't object.
No, the power company wouldn't, Mr. Payne. But the building superintendent does. The wiring just won't take it. Year after year, we've seen every advantage this building could offer canceled. Disappeared, just like this furniture. Comfort, efficiency, convenience. Until now, we can no longer conduct an up-to-date business. We're losing money by staying here. Look, this is all you have to sell. Space. Usable, profitable, rentable space. But if you can't give your tenants plenty of electric power, then you just ain't got it.
Well, you can see the pickle Elmer's in. But there's hope for Elmer because he's discovered the most important figure of all, the question mark. Yes, Elmer, it's all right to make a saving, provided it isn't a false economy. There's hope for Elmer because now, whether he likes it or not, he's face to face with one unchangeable fact: progress. Here, let me show you what I mean. As Mr. Smith pointed out, a commercial building has nothing to sell but space. And when When 1010 Main was built, it was thoroughly up to date, architecturally and mechanically. And it still is. But thanks to Elmer, the wiring is not up to the future. And since then, electrically, we've had progress. Boy, how we've had progress. Lighting levels have gone up and up. Modern lighting systems, modern fixtures, modern electrically driven office equipment, business communication equipment. We have modern electrical appliances in kitchens that can cook a roast faster than Elmer's radiator can come to a boil. Elevators that go up and down almost as fast as he drives his car on the level. In all types of commercial buildings, we have modern climatic control, year-round comfort. And if you should want to add it all up, well, nowadays you'd use one of today's modern calculators that have done so much to streamline business and commercial practice. But any way you add it up, this is about what you get. And this is something that's happening in almost every commercial building 20 years old or more.
Wouldn't you know it? The goo's running out of the cables. Dang fuses are going off like firecrackers on the 4th of July. We're going to have to tear out the walls and pull in more wire.
You see, progress can be painful because the other side of progress is obsolescence. The faster the progress, the faster the obsolescence. How fast has it been? Well, you can see here what's happened. Total power consumption in commercial buildings in the past 20 years has increased 5 times. Typical lighting levels have gone up from 15-foot candles in 1935 to 50 today. Air conditioning load has grown by leaps and bounds, not to mention the fast-growing use of electric business machines. 10 years ago, commercial buildings averaged 2 watts per square foot of floor space. Now they're using 10 watts. Just from those figures, it's obvious what happened to poor Elmer. He got his fingers caught in the wheels of progress. Of course, that doesn't make him unusual. The only trouble is that of all people, Elmer's probably the least capable of coping with progress. And that's most unfortunate when you consider that Elmer is now on his way to evaluate the proposals of the architect and engineer on his company's new building.
Just our luck. Our proposal all ready to fly, and then at the last minute they ring in this Elmer Payne character. He says no, we have to start all over again. Just ask the old-timers around here what Payne did to 1010 Main.
I know. Masonry like the Great Wall of China. Foundation like Circus Maximus. And about as much wiring as a Christmas tree. A small Christmas tree.
And since then, he's neither learned anything nor forgotten anything. Well, it's now 30 seconds to the hour, and unless I miss my guess, yep, there he is. Couldn't be anybody else. Right on the dot. And 20 years behind the times.
Look, Perry, I'm not going to let my engineering plans be all scrambled up by some prehistoric pencil pusher.
And what are you going to do about it?
That's a good question. What am I going to do?
Well, I'll go ahead and discuss the architectural layout. Then it's up to you. If you don't have something figured out by then.
Yeah, I'm a dead duck.
Well, how do you do, Mr. Payne? Come in, come in. Glad to see you. We've been looking forward to this meeting. I'm Perry Black, the architect.
How do you do?
And this is Carter Magnus, who's responsible for the engineering.
How do you do, Mr. Payne?
Here, let me take your things.
Well, shall we get down to business?
Oh, certainly. I know you're pressed for time. Now, if you'll just sit here. I'll start out by going over the elevations and floor plans. Now, I suppose you're already familiar with the basic design. So let's take a look at the lobby details. And you'll find this architectural layout complete in every detail. Now, here's section 8 for the elevator. That's followed by the tunnel entrance details. Whereas over here on this page, we have general loads. Mr. Payne, you'll see, deals with the concrete protection between portion and metal steel. And that's followed over here by the foundation detail plan. And in the upper right-hand...
Well, the conference got off to a good start. Elmer was agreeable. Too agreeable, if anything. seemed to be impatient to get on to the next order of business. Finally,
So I think you'll agree that architecturally, the building will be structurally sound, with a maximum of highly desirable rental space.
Yes, quite right. Now, I hope your proposals for the electrical system are equally sensible.
Why, of course, Mr. Payne. And you'll find that Carter, Mr. Magnus, has some interesting proposals in that direction.
Before he does, I want to make it clear.
Before you do, suppose you at least let me show you what I have in mind.
I merely wanted
Now,
to say...
why don't you take a look at what he's got, Mr. Payne? I think you'll find it very interesting.
But you don't understand. I don't want...
Of course you don't. We'll get to that a little later. First, what I have drawn up here is a basic plan for a 480Y slant 277-volt power distribution system, or 265 slant 460 volts as it's sometimes called. I propose to bring in the primary power from the utility line right here. In this case, 4160 volts is available. And here is the entrance switchgear. Then, in the basement, install a load center unit substation.
What in tunket's that?
Well, it's a completely enclosed unit that contains the transformers and the circuit breakers in a single, safe, compact metal-clad package. The transformer here reduces the primary voltage to 480 volts. The rest of the substation is made up of fully enclosed circuit breakers, which control the circuits and protect the building and its electrical equipment from line faults or short circuits. The switchgear has the same function as the fuse box and the power switch in a private home. In a commercial building, this unit substation here takes the place of this conglomeration of an assortment of transformers and exposed live parts.
You mean all this wire and hardware is packed into that one box?
That's correct. One installation. All you need is a little floor space. Then, from the substation, we'll run a 480-volt feeder to the motors for the pumps, elevators, ventilators, and air conditioning system. Then 2 risers will carry 480Y 277-volt power to the floors above. On each floor, we'll have a panel board from which branch circuits will carry 277 volts to the ceiling lighting fixtures, while a dry-type transformer will reduce the voltage to 120 for the plug-in receptacles. Now, I think you'll agree...
What makes you think I'll agree to anything?
Well, I know how much store you put in economy.
Economy?
Mm-hmm.
I've just visited the building at 1010 Main. I'm beginning to get some new ideas on economy.
I expected that. And for that reason, I've drawn up an alternate plan for the purposes of comparison. Now, in this case, we'd use a similar unit substation to reduce the primary voltage to 208 volts. This voltage is carried to the circuit breakers here and then to the motors. 4 risers would carry 120 volts to each floor for ceiling lighting fixtures and plug-in receptacles. However, we strongly recommend this, the 480-volt system, because it's the latest development in commercial power distribution.
You realize that I'm not a great enthusiast for the latest thing.
Yes, sir. No, sir. But it's more economical.
Costs less? High voltage costs less than low voltage? Why?
Well, as you know, electric power is the product of volts times amperes. The lower the voltage, the higher the amperage.
I know it now.
And the higher the amperage, the more metal necessary to conduct the electric current.
More amperes, more conductor? I see. Go ahead.
So, with higher voltage, you get the same power with lower amperes. Therefore, less conductor. Therefore, less metal. Therefore, lower cost.
But wait a minute. How about these little transformers you have here? They're extra, aren't they?
Yes, but their cost is minor compared to the saving effected in the entire system. With 480 volts, 2 risers. 208 volts, 4 risers. To have the same power at the lower voltage requires...
Sorry to break in at this critical point, but simply because it is critical, I thought I'd better. That explanation of Carter's is going by pretty fast. And I can show you on film better than he can. Here we are in the basement of a modern commercial building to see the actual system Carter's talking about and Elmer's thinking about. the 480-volt system. The primary power, 4160 volts in this case, comes into the building through this metal-clad switchgear and then to the unit substation. And this is the transformer that steps the primary voltage down to a usable 480 volts. From the transformer, the 480 volts goes to a circuit breaker, which provides switching and protection for the transformer secondary and low voltage bus. Then a series of feeder circuit breakers supply the various risers and loads throughout the building. They protect the feeders and risers anywhere in the building against overloads and short circuits, guarding against damage to the building and its contents. Now suppose that the 4160 volt supply at the right is interrupted. To maintain power to the building circuits, you have a second 4160 volt primary power supply to the left with transformer and circuit breakers, which normally carries only part of the building load, ready to take over the emergency load and maintain electrical continuity in the building. Now, if 480 volts is available directly from the power company, all you need is this central compartment containing the 480 volt circuit breakers. That's the unit substation. One compact, safe, easily installed, factory assembled unit. All you have to do is move it in and connect it up. Here the feeders and risers go off into your walls. That's the part of the system you can't see, but it's important. So to show you, I've arranged a sort of breadboard model. The actual system condensed for display and demonstration. Some of that 480 volt power from the basement comes up the risers to the floors above to supply the power and lighting. Here, for instance, is a small motor using 480 volts. From panel boards on each floor, 277 volts is taken off directly to operate the fluorescent lights, which contain ballast rated at 265 volts. Then another circuit from the panel board supplies this dry-type transformer, which converts 480 volts to 120 volts. Then this second panel board supplies that 120 volts for the plug-in receptacles for desk appliances, business machines, and whatnot. From that substation we saw in the basement, feeders carry some of that 480 volt power to run your large electric motors. That's the system, simplified for purposes of demonstration. Now, you heard Carter say that it uses less metal than the lower voltage system. Well, don't take his word for it. Here are the circuit breakers for the two systems. Kilowatt for kilowatt, the 480 volt system uses smaller circuit breakers, or of course, correspondingly fewer of the same size. But fewer or smaller, as here, the cost is less, and they require less floor space. Here are 480 and 208 volt feeders and risers. Same capacity, but which takes less metal, which therefore costs less, which leaves more rentable space. And remember, there's another saving too, just as invisible as electricity, but just as real. You see, these feeders and risers in an actual installation may be 100 or several hundred feet long. You all know that as electricity is pumped over any conductor, the voltage drops. There's a formula for voltage drop, and it's worth knowing what it means. Simply this, that the percentage of voltage drop over any conductor decreases with the square of the voltage applied. In other words, twice the voltage, 1/4 the percentage of voltage drop. This means you get more of the power you're paying for and better performance from all your electrical equipment. Now, those are just some of the facts about the economy of high voltage systems that I hope Carter has been able to get across to Elmer. With a feeling for economy, Elmer ought to be a pushover for that argument.
So you see, you save in first cost, you get more power at the outlets, you have more electrical capacity, and a more rentable, profitable building.
Very interesting. A very good presentation, Carter, but
In other words, it's more economical.
as I've tried several times to tell you, I'm not primarily interested in the same false economy we practiced when we built 1010 Main. That 480 volt system may be economical, but what I want is a building that's, well, you might say, up to the future.
Up to the future?
I want that new building to be as rentable 20 years from now as on the day it's built.
Well, Now you're talking our language, Mr. Elmer. You're going to get exactly what you asked for. Economy plus future adaptability. Because with this system, you can save money and at the same time build in flexibility.
Good old
and capacity
Elmer.
for
From
future
advocate of the
standalone.
past to prophet of the future
I
in
would like to
one
refresh your
painful
memory
lesson.
just briefly
And
about
speaking
the
of
two points I
prophecy,
mentioned earlier
there are some
in the
interesting
presentation.
future developments in
Number
store
one
for
is
commercial
the
building.
and the compactness.
Remember that chart I showed you earlier?
Substation. As contrasted with the photograph that I showed you earlier.
Well, this is the rest of that chart.
As you can see today.
The next 20 years of electrical growth. Power consumption in commercial buildings will increase 1,100% over 1935 levels, 140% over today. Air conditioning capacity up 250% in the next 10 years alone. By 1975, typical lighting levels will climb as high as 200-foot candles, an increase of 300%. Elevators increasing 20% in number and power requirements. And use of electric business machines will rise an astounding 600%. And these are only the electrical devices we already know and use today. What about new applications, new devices? Products of American imagination and ingenuity that will come off our drawing boards and production lines of the future. Mind if we take a look? Thanks. Sort of like taking a peek into a crystal ball. Say, now isn't that something? A moving sidewalk. Looks like we're going to have better and faster ways of handling people, getting them in, to the merchandise, and out. And what the deuce? Oh, I see. It's an automatic packaging machine. Automation coming out of the factory and into the business and commercial world. And next? Well, what do you know? Flat screen television. That I'd like. And so a lot of people that use it to streamline business communications. Well, you don't need any crystal ball to realize the cumulative effect of all this on commercial power distribution. Expanded use of present devices and appliances, plus the adoption of new devices and applications, requires every building power distribution system to be flexible and expandable to meet future needs. And this 480-volt system, with its low first cost, you can afford to install ample future capacity. Ready for plugging in. And when you need it, just plug in on the outlets provided in the busway. Or simply attach new circuits to the panel board. No structural change. No walls to tear out. No expensive new installation. Because the capacity for increased building loads is already in your walls. Now, this isn't just theory or dream stuff. It's reality, here, now, today, and being put into practice in steel and concrete and copper in America's most modern commercial structures. In Pennsylvania's new Commonwealth office building in Harrisburg, one of the General State Authority projects, the 277-volt lighting, as against 120 volts, alone saved $20,000. In Menands, New York, the New York Telephone Company's new accounting office building. By no means a skyscraper, but the saving through 480-volt power distribution came to some $14,000, with capacity designed in for double the present electrical load. In their new North Central Home office building in Minneapolis, the Prudential Insurance Company took the high voltage road to a saving of approximately $50,000 in electrical costs. School buildings, because they're spread out so far horizontally, can profit greatly by the use of high voltage power distribution, even though more than half their load may be at 120 volts. It is estimated that our population growth will require construction of 100,000 new classrooms per year. Probably 25,000 of these classrooms will be suitable for economical use of 480-volt distribution. With an average saving of $500 per classroom, this would bring a saving of over $12 million in taxpayers' money. Well, there you are. New building or old building. That 480-volt system offers the best insurance against electrical obsolescence. Economy, both in first cost and later expansion for future capacity. The loads are sure to come. The bright light of the electrical future shines on our drafting boards today. Its searching glare will not be kind to sins either of omission or commission. And that brings us back to the case of Elmer Payne. That's my job, you know, to see that everything turns out right in the end. I wonder if Elmer's seen the light, and... Uh-oh, they're breaking up now. And the question is, did he or didn't he?
It was time well spent. I wonder what time it is.
4:30.
Oh, must hurry. Well, goodbye.
Goodbye, Mr. Payne.
Bye, Mr. Payne.
Elmer Payne, the voice of the past, with a question mark added. And question marks are dangerous things. They can change your point of view, influence a man's whole life. There's no telling what a thing like this can lead to, even with Elmer.
Well, good morning, Mr. Payne.
Will you bring your book, please, Edna? A memo to Mr. Naxon, please, Edna. Dear Mr. Naxon, according to my evaluation, the proposals of our architect and engineer will save enough on the electric power system of our new building to permit us to install the same modern, flexible, adaptable equipment in 1010 Main. And Edna, if Mr. Naxon should ask for me today, please tell him that I'll be tied up enjoying myself.